Hey guys, hello everyone. Hope you guys are doing well. Welcome back to our channel. So today we start a new series on polynomials. We are going to discuss first the key concepts and then move on to problems, covering all the exercise problems from standard 10 mathematics on polynomials. And then I want to tell you, if you have a particular problem as a doubt or you want my help in solving that, please do ping me that question in the comment section and let me know. I'll definitely do a video on that. Stay tuned for more videos on different chapters covering standard 6 to inter, and let me know if you have any specific question for me to solve. I'll definitely help you with that. Having been said this, let's move on discussing the key concepts of polynomials today. So, first, what is a polynomial? A polynomial is an algebraic expression of variables with non-negative integer power. Okay, an algebraic expression of variables with non-negative integer power. For example, if we take an algebraic expression 2x plus 5 or 3x square plus 2x plus 6 as my examples, here we see that there is a constant, there is a variable. So variables are the ones whose values are not constant, not defined, it can change, and constant are the ones whose values are predefined and cannot be changed. So an algebraic expression contains of both a variable and a constant, and here it is said to be a polynomial because it has different terms. So suppose if I take this as an example, it is called a linear polynomial, and this expression is called as a quadratic polynomial. Why and how? Okay, just a simple logic for now. Here we see that it is of variable x and x has power 1. That means it is a linear polynomial. Here we see we have x square, we have x. So the highest power of x is 2. Therefore, it is said to be quadratic polynomial. So whenever we solve this in further steps, if we solve this quadratic equation, we'll get two values of x satisfying this equation. That is why it is said to be quadratic polynomial. So a polynomial is based normally constructed using constants and variables with non-negative integer power. Remember that the power of the highest value of the variable should be non-negative. Suppose we have a polynomial 1 by x minus 1. If this is not a polynomial, because this can be written as x to the power of minus 1. So it is a power with a negative integer. That means this cannot be said as a polynomial. For another example, if I take root of 3x cube, this is also not a polynomial because it is having a power of root. We just need to have the power, a power of a positive integer, and that can be only said as a polynomial. If we see a polynomial with 1 by x square, this is also not a polynomial because I can write it as x to the power minus 2, a negative powered integer. That means this is not a polynomial. Hope you have understood how to classify a polynomial and a non-polynomial. moving on with types of polynomial and degree of polynomial now. Okay, our next concept is degree of a polynomial. Suppose, for example, let us take the same thing, 3x square plus 2x plus 6 is equal to 0. We have a quadratic polynomial because the power is 2. Now, what is said to be degree of a polynomial from here? We see that there are variables. It is a equation of variable x, polynomial of variable x. Now you have to compare the powers of the variables in the equation. The highest power in this equation will be the degree of the polynomial. Here we have x to the power 1 and here we have x to the power 2. That means the degree of this polynomial is 2. Suppose we have 3x plus 2 is equal to 0. Okay, in our next example, we have 3x plus 2. We see that the variable x is having the power 1. That means this is the highest degree for this equation or polynomial and therefore the degree is 1. This is the way that we find the degree of the polynomial. It's basically the highest power of the variable available in the polynomial. Okay. Next we move on to, okay, let's see another example. 4x power 4, 3x cube, 2x square, 3x plus 1 is equal to 0. It's a biquadratic polynomial. That means power raised to 4. So here what is the degree? We see that variable x is having 4 types of powers here. One is 1, then it is 2, then it is 3 and then it is 4. So what is degree of a polynomial? It's the highest power of all the variables available in the polynomial. So here the highest power is 4. That means degree for this polynomial is 4. So moving on with types of polynomials, we have zero polynomial, linear polynomial, quadratic polynomial, cubic polynomial. Let's see how do we classify them. So first we go with zero polynomial. I would like to take 2 by 3, 8, or if I tell f of x is equal to 2 by 3, f of x is equal to minus 1 by 2, f of x is equals to 8. So any equation having only constants, no variables and no coefficients of variables, nothing, only constants, these are said to be zero polynomial. Okay, and we move on to linear polynomial. To make it simple, it's in the form of ax plus b, that is 2x plus 5 is equal to 0. This is a linear polynomial because the value of the variable power is 1 and hence it is called linear polynomial. And now again we have a binomial, a monomial, trinomial, to be classified more. How can we define this? A binomial will always have two terms. That is, this is a binomial because there is one term called 2x and the other term called 5. So 2x plus 5 is a binomial. For monomial, it will be only having one term, that is 3 by 2x, suppose, or 5x. There is only one term in the equation. That is why it is called a monomial. And for trinomial, it will obviously have three terms. Suppose 4x cube plus 2x square plus 3 is equal to 0. If I take this as an example, it is having 3 terms. That is why it is a trinomial. Okay, just for your information, a linear polynomial would be of the form ax plus b is equal to 0 with power 1, and quadratic will be ax square plus bx plus c is equal to 0. Here a is the coefficient of x square term, b is the coefficient of x, and c is a constant term. The third one is the cubic one, which will be in the form ax cube plus bx square plus cx plus d is equal to 0. Okay. Now, if I draw a graph for the solutions of x, suppose I take an example of a linear polynomial 2x plus 5 is equal to 0. Now to find the value of x, what I will do is take the constant term to the other side, it will become minus 5, and I'll take 2 to the other side, it will become division because it is multiplication here. Moving on to other side, it will become division, and hence our solution would be x is equal to minus 5 by 2. Now if I substitute this x value here, our equation should be equal to 0. So 2 into minus 5 by 2 plus 5 is equal to 0. 2 cancel, minus 5 plus 5 cancel. So 0 is equal to 0. That means our solution is correct. This is the way of verification you can do. Be it for quadratic or cubic, you can always substitute your answers in the equation and see if it is equal to 0, that means your answers are correct for the values of x. Now since it's a linear equation, it will have only one solution, one value for x, and if you draw a graph for this, it will always be a straight line. If I talk about quadratic equation, there will be two solutions because the degree is 2. So for two values of x, how will you draw the graph? If suppose a is greater than 0, it will be a upper parabola. It will be, the graph will be in the shape of parabola and it will be like U shaped, turned upwards. And if a is less than 0, then it will be a downward parabola. Now a is the coefficient of the term x square. Okay, so based on that you can always check whether your graph is giving this correct shape or no.